All right, this lesson is going to be all about square root and cube root functions. We're going to start with just basic parent function. So remember, a parent function is just the most basic type of square root function, most basic type of cube root function. Basically, nothing is happening to the graph. We're not moving it left, right, up, down. We're not stretching it, shrinking it, no reflections. It's just, if you just take the square root of x, what does that graph look like? Notice for the square root function, the domain and the range might be limited. That's because we can't take the square root of a negative number. So every time you have a square root graph, you are going to have to pay attention to what is the domain going to be, and that will also affect what the range is for this particular type of function. For a cube root function, the domain and the range will always be all real numbers, so that's pretty nice and easy to remember, because you can take the cube root of absolutely any kind of number and get a real answer. So let's do a few graphs here. Starting with this square root function. So first of all, because it's a square root function, we know the domain is limited. We know we cannot take the square root of a negative number, which means the radicand, what's underneath the radical, has to be greater than or equal to 0. And if I solve this, I get that x needs to be greater than or equal to 0. That means my domain is x is greater than or equal to 0. And when I make my XY chart, I cannot plug in any numbers less than 0 because that's not part of our domain. So when I make my XY chart to get the square root function, I'm going to plug in numbers. I'm going to try to plug in numbers that come out nicely to start. So like I can plug in a 0 because then I'm just taking the square root of 1/4 times 0, which is 0. So first point, 0, 0. Then I'm going to skip all the way up to 4. Because when I plug in 4 for x, I have 1/4 times 4, which is 1. And the square root of 1 is 1. 1, 2, 3, 4, 1. But then there's not really another nice, pretty square root that we can go from here. So our answers might get a little messy. That's okay. I can plug in 8, though, and it won't be as messy because I'm just taking the square root of 1/4 times 8, which is 2. But you will have to use your calculator on some of these then. So we get that that's about 1.4. So let's see, 4, 5, 6, 7, 8, 1.4. And there is my square root function. So now that I have the function graphed, it's a little bit easier to see what our range would be. You can see that every one of these points is above the x-axis. So for this case, my range is going to also be everything greater than or equal to 0. Let me show you an example of a cube root function now. So cube root functions, the domain is not limited. So let's make sure when we plug some numbers in, we're plugging in numbers that are both positive and negative. And so that my numbers come out pretty nicely, I'm going to plug in numbers where this cube root is going to come out nicely. So for example, perfect cubes are goodness sakes, 1, 8, 27. So those are the types of numbers I want to plug in here. I'm not really sure how to scroll that back up. Oh no. Let's try that again. All right, x cube root of x. So I'm going to plug in -8, -1. 0 is also a perfect cube. 1, 8 to get us started. So -3 times the cube root of -8. The cube root of -8 being -2. So that's -3 times -2, or 6. So first point is -8, 6. Then -3. Cube root of -1 is -1, so -1, 3. -3 times the cube root of 0 is 0. -3 times the cube root of 1. And then -3 times the cube root of 8. All right, and then we have our little cube root S curve, and our domain and range would both be all real numbers here. All right, so these transformation rules are actually the same rules that we've done with other types of functions. So if you are adding or subtracting to the inside of the square root sign or cube root sign, that's a horizontal translation, that's left or right. If you're adding or subtracting to the outside, that's up or down. And then all of these are the same too. Multiplying to the outside is a vertical stretch or shrink. Multiplying to the inside is a horizontal stretch or shrink. We've got the reflections. That's when you're multiplying by a negative. These are the two we care the most about because those are going to affect the domain and the range for the even root functions. For cube root functions, it's not going to really affect anything. But if you're adding or subtracting something to the radicand, that's going to limit what numbers you can plug in for x, because we know that we have to take the square root of positive, or we cannot take the square root of negative numbers, I should say. So using that information, let's start by just recognizing what some of these transformations are. So inside, adding or subtracting to the inside moves it left or right. That would be right 3, up 4. Inside means left or right, so that's going to move the graph left 1. And then multiplication to the outside is a vertical stretch, in this case of 2. So again, what we're saying is you're taking that original parent function from the very first slide, and then you're going to take that function and move all those points right 3 and up 4. Or we're going to multiply the function by 2 and then move all those points to the left 1. Same thing happens with cube root functions. So this would be a reflection over the y-axis, and then the 8 would be a horizontal shrink of 1/8 because it's happening to the inside of the function. Here we have a reflection over the x-axis, and this would move the graph down 2 from that original parent function. So when you're matching graphs, you're just using those transformation rules. We'll go through this pretty quickly. This one, we're taking the parent function and going left 2. Well, this is the one that looks like it's going left 2, so A goes with A. For B, we're going right 2, so the one that got moved right 2 was D. For C, we're going left 2 and down 2, so that's B. And then the only one with the reflection is D. That negative means it's a reflection, which means it's upside down, reflection over the x-axis. So that's why it goes with C. So you can see for each one of these how the domain would be affected. So like for A, this first graph, our domain would be everything bigger than -2. The same for B. This domain would be everything greater than or equal to -2, but this one, the range is also affected because it got moved down 2. So our range on this one would be everything is bigger than -2 on our y. For the C, this one's really affected because it's flipped upside down. So our domain is still x is greater than or equal to -2 because we moved it left 2. But because it's flipped upside down, our range is actually everything less than 0, less than or equal to 0. And then last one, D, if we're talking about domain and range here, our domain is everything bigger than 2. Our range is everything bigger than 0. We can tell just by looking at it where that point is. Okay, so when we're graphing these, I think the easiest way, with multiple transformations, the easiest way I think to start is thinking about where that first point's gonna go, like kind of the anchor point. So we're taking our parent function and we're going right 3 and up 2 from there. And so 3 would be a great number to plug in first. We'll call 3 our anchor point because we're moving everything in that direction. So if I plug in 3, I have negative 2 times the square root of 0 plus 2. I'll go through this part fairly quickly. So we have 0 plus 2 is 2. We already had that point on there. Let's do some more points. And you can think through these a little bit more to plug in numbers that are going to come out evenly. It's not always super possible, but in this case, I can plug in 4. 4 minus 3 is the square root of 1, which is 1. That comes out nicely. So I have negative 2 times 1 plus 2 is 0. So 4, 0. 5 won't come out nicely. 6 won't come out nicely. But if I plug in 7, I have the square root of 4 when I take 7 minus 3, which is 2. So we get negative 4 plus 2 is negative 2. So 4, 5, 6, 7. And I guess I should have started with finding the domain. And so your domain, we know this has to be greater than or equal to 0 because that's what's underneath the radicand, or radical. It's underneath the radical. It is the radicand. So we know x has to be greater than or equal to 3. So this is the point that we're starting at. And then I could keep going and plug in more numbers that are greater than 3. But I've already kind of got my curve from there. So our domain is x is greater than or equal to 3. I should have done that first. Our range, sometimes you can look at the range in advance or by looking at the transformations, or wait till your graph is done and kind of see what's happening. But it's going down, so y is less than or equal to, and the highest point is on the y is 2. So another example of a cube root function, but this time I should say, we don't have to worry about the domain since it's a cube root function. You can kind of think through in advance what numbers to plug in so that you're taking the cube root of nice, pretty numbers, but you don't have to do that. Your numbers can be messy. That's okay. But make sure, because it's a cube root function, you're plugging in both positive, you're getting both positive and negative. We should get a nice S curve. And again, sometimes I think it's helpful to start with that like anchor point. So this graph is being moved left 4 and down 1 from the parent function. So I'm going to go left 4 and down 1. Right, if I plug in negative 4, I get 3 times the cube root of 0 minus 1. Right, I know that point's going to be on that graph. So that's a nice anchor point to get me started. I know if I plug in negative 5, I'm going to be taking the cube root of negative 1, which comes out nicely. If I plug in negative 3, I'm going to be taking the cube root of positive 1, which comes out nicely. Let's see, I also want the cube root of 8. Those will come out nicely. So if I plug in 4, I get the cube root of 8, which is 2. So that comes out nicely. And then to get negative 8, I'd have to plug in a negative 12. But I can still do that. Let's negative 7. All right, so then we got these points, 1, 2, 3, 4. There's negative 5, negative 4. There's negative 3, 2. We have 4, 5. And negative 12, negative 7 would be off our graph, but you could get the idea from there. And domain and range would both be all real numbers. Just be careful when you're graphing square root functions. Pay attention to what your domain is. Pay attention to what numbers you can plug in and what numbers you can't plug in. We're not going to graph these two examples, but I just want to remind you that the 1/2 power is the same thing as a square root. So this is the same thing as saying 2 times the square root of x plus 1 minus 4. And this is the same thing as saying negative 2/3 times the cube root of x plus 1. Only x is being raised to the 1/3 power, or else there would have been parentheses around it like that. Since there weren't parentheses, I don't know how to erase, but we don't have to worry about that. And so then you would make your XY chart from here. Obviously, the domain and range here are all real numbers. But over here, we're moving left 1 and down 4. So our domain, everything is going to be greater than -1 because we moved to left 1. We moved down 4, so everything in our y needs to be greater than or equal to -4.